Welcome to the tutorial video on the Ball Drop Lab. This will be an introduction of how to use Logger Pro to do some video analysis. First thing you need to do is find your Logger Pro. On PCs, it'll be in the Vernier software folder. It may be on your desktop, but you're going to go ahead and open up Logger Pro. The first thing you need to do is come up here to Insert, and you're going to insert the movie that you've already made. You'll have to navigate to wherever your movie is saved. Mine is in my Intro to Energy folder. I'm going to insert that movie into Logger Pro. I'm going to go ahead and make this the full size of the screen. I'm going to click these three red dots, which is going to open up the Tools menu. On the right hand side, you can see there's a list of tools now. First thing we need to do is we need to add a scale to this video. We need to tell the computer how big objects are in this video. So we've included a meter stick in the video itself. You can see this is the beginning of the meter stick. And even though I can't read it, I know that this is 10 centimeters, 20 centimeters, 30 centimeters, 40, 50. So I'm going to measure from the floor up to here. And that was 1, 2, 3, 4, 5. So that's 0.5 meters. So that tells Logger Pro how big objects are in the movie. The next thing I'm going to do is I'm going to set my origin. I'm going to use this right here. And I want my origin to be right here at the bottom where my floor is. The next thing I'm going to do is I'm going to go ahead, click on the red dot, where it's going to start adding points. I'm going to come down here. I'm going to advance the video one frame at a time. Until I can start to see when the ball is released. I'm going to back it up several frames, even before the ball is dropped, and I'll start tracking data points right there. I'm going to get a little bit of information before the ball actually drops. So I'm going to put my crosshairs on the ball, and every time I left click with the mouse, it's going to add another data point. And you can see all the points starting to add over here on the side. It's just starting to drop the ball. I'm going to try to keep my crosshairs in the center of the ball. You can see that the ball starts getting blurry, but I'm always going to try to aim for at least the center of the blur, even if I can't locate the center of the ball. The more careful and the more accurate that you are in placing your data points, the better that your data will be and the better that your graphs will be. So it's important to go slow, to have the video as large as possible so you can see as clearly as possible. You're going to continue to add data points. You want to make sure that you get at least one bounce. If your video is longer and you get more than one, that is great, but not necessary. My video is not much longer, so I'm going to go ahead and track my ball all the way to the end of my video. And you can see the little gray bar is all the way at the end. That tells us that we're at the end of the data. So I'm going to go ahead and use this tool to select a point. That keeps me from putting extra data points in my video. I've now done all the analysis on the movie I need to do. Now we can go ahead and look at the data. So I'm going to shrink down my movie. If I click on this graph, the movie goes away. And now I can see that the data in reds is the X position. That's the horizontal position of the ball. And I also have the Y position in meters. That's the vertical position of the ball. For this lab, we only need to be concerned about the height of the ball, the Y position. So if you right-click in this white space and select Graph Options, you can come over here to Axis Options, and you can uncheck the X data. It is no longer selected. And when I click Done, the red dots are no longer displayed on my graph. They are still in my data table. If I click on my data table and expand it, you can see that the X position data is still there, along with the Y position, the X velocity and Y velocity, as well as the time. But it only displays what you have selected. The graphs that we need to create from this data, while this position graph is nice, we are interested in energy. So I'm going to insert a new graph, and it's going to guess what kind of graph I want, and that's not what I really am interested in. So I'm going to right-click in the white space, select Graph Options. I'm going to title this EK, which is kinetic energy, and EG, which is gravitational potential, versus time. And this is the graph that we're going to be creating. I'm going to click on Axis Options. I'm going to unselect the Y velocity. Click Done. And it says nothing will be displayed. That's okay. So this is the graph that we're going to be creating right here. To create this graph, we need EK and EG. To do that, we need some more data. We're going to come up here to the data, and we're going to create a new calculated column. This first one will be kinetic energy. The short name for kinetic energy is EK, and the units are joules. And the expression for kinetic energy is 1/2. So I'm going to do 0.5. The time sign is just the asterisk. You're going to need the mass of the object. So you're going to have to do that experimentally. You have to put it on a scale and find out the mass of your object. Make sure that it's in kilograms. I'm going to use 0.25 for the mass of my object. Your mass will be different. And I'm going to do multiplied. I'm going to come down here to the parameters. Nope, come down here to the variable column. And I want to use the Y velocity. Kinetic energy is based upon motion, so we want to use the velocity. And since the ball is moving up and down, we want the Y velocity. And then the functions. We'll just go ahead, we'll do asterisks, and we'll do y velocity again. The equation for kinetic energy is 1/2, that's the 0.5, times the mass, you get to measure that, times the velocity squared. So that's why I have velocity times velocity. And now when I click Done, it's going to create a new column for me that is EK, and that's my kinetic energy. I'm going to create another calculated column. This one is for gravitational potential. The short name is EG, and this is also measured in joules. The expression for gravitational potential energy is just the mass. So whatever your mass was before, you have to measure it, make sure it's in kilograms, times gravity. We're just going to use 10 for gravity, multiplied by how high the object is. So once again, for the height, we're going to come over here to the variables, and we're going to use the y variable. That's going to tell us how high the object is above the floor. So this is mass times gravity times height. We go ahead and done. And now this has created another column for EG. So now that I've created those columns, I can put those columns on my graph. I'll just make this one a little bit bigger. I'm going to right-click in the white space, select Graph Options, and I can use this to scroll down. And now the two columns that we created, the kinetic energy and the gravitational potential, are checkable items now. Those are things that you can select. So we're going to put both of those on the y-axis. We're going to click Done. And now we've got a graph of kinetic energy in purple, or whatever color you selected, and gravitational potential energy in red. And you can see that as one energy decreases, the other energy increases. And that's a nice looking graph. We're also going to create another calculated column. So once again, new calculated column, and this is going to be total energy. The short name for this is going to be ET, and this is also measured in joules. And this is simply going to be kinetic energy plus gravitational potential. We want to know what happens when we add those things, what the sum of that energy is. So we've got a column for total energy. I'm going to insert another graph, and it already picked total energy for me. It's the most recent column, but you can certainly go in here to Graph Options and pick whatever you want. Sometimes it'll guess right, sometimes it won't, but I did want total energy. I'm also going to come over here and give it a title. Total energy versus time, and hit Done. And we can see that even though this graph is not perfectly straight, it certainly does look like a nice horizontal line. Something happens, and there's another relatively horizontal line. So something is constant here, something happens, and then there's another something that's constant here, although at a different and lower level than here. And part of your lab will be to discuss what those graphs represent. A little bit of housekeeping of just how to make things look nice. You can come up here to Page and click on Auto Arrange, and it will automatically put all the things on the screen so that you can see them. You're going to take this data, these charts and these graphs, you're going to insert these into a Google Doc. The way to do that is to select one of the graphs, whichever one you're interested in, and you want to go ahead and make that graph the entire page. You can then do a screenshot of this graph. You can also just right-click Copy. And if you have a Google Doc open, I'm just going to go ahead and make a new one. I can right-click and click Paste, and it will paste that graph into my Google Doc. If I have all the graphs kind of shrunk down, and I click my total energy graph, and I say Copy, and I paste that into my Google Doc, then it's going to paste the kind of shrunken down version. And once again, since this is a Google Doc, we're not wasting paper, so there's no need to have it all scrunched down. Make sure that if I'm going to put this graph in here, I'm going to make sure that it's the full size, that it looks good, that it's got a title, the axes are labeled. So now I'm going to copy this, and I'm going to paste this. And this second graph is much bigger, it's much easier to read. So I'm going to go ahead to this one and delete that one. So not only can you create graphs from the different videos, but then you can use these different graphs, copy and paste those, and insert those into your Google Doc to create your lab report.